Hello YouTubers! Today I'm going to build a very useful device. This will be a motion detector. So the idea is if this device detects movements, will send a notification to my phone as an email or pop-up notification. This device will be battery powered, and also idea is that this will be looks like a product, not as a prototype. So I'm going to print using the 3D printer enclosure. So let's do some shopping. First we need to find a motion detector module. We can go and search in the Amazon for motion sensor module and many of those such devices. I choose this particular one. It has a very good price. Additionally have a adjustable timing and sensitivity. Can be powered between 4.5 and 20 volts, and output level for the digital signal is 3v3, which is usually most common voltage level for IoT modules. Next we need to buy the IoT module. I choose the Cricket from Things on Edge company. The advantage of that module is required zero coding, no flashing, no coding, no cloud knowledge. It will allow to build the device in minutes, 5-10 minutes. Also could be powered by a battery directly. So this will allow us to build our motion sensor in very short time. Now we have a small problem to solve. We can power up this motion sensor using the battery, 9 volts battery. However, the IoT module, the Cricket, can be powered between 1 and 3.5 volts. So it cannot be connected directly from the battery. So we need to somehow reduce from 9 volts to 3.3 volts. We're going to use the DC to DC step-down regulator. So we connect this regulator directly to the battery, and the output we adjust to 3.3 volts, which is perfect for this IoT Cricket module. So now if we go to Amazon and search for a DC to DC buck converter, we can find many products, very good price, usually in 6 packs, 8 packs. This particular one, we can set the output voltage. So we can set from 0.8 to 20 volts and can be operated from 4.5 to 28 volts. So it perfectly fits into our 9 volts battery. Once we got all parts, let's do unpacking. Let's explore entire schematics. I will build everything in FreeSync so we can see how everything will connect together. Before we connect power supply to the IoT module, we need to make sure we set up the right voltage output in the DC to DC regulator. Otherwise, if it's too high, it might damage the board. So it's very important we set up to roughly 3.3 or 3.5 volts. Once we connected the power to the Cricket board, we can test by pressing configure button and LED should blink. Next, before we connect the motion sensor to the cricket board, we need to reduce the time of the high signal when movement is detected. The reason for that is if this timing is more than 5-6 seconds, we will have multiple duplicated events. So this is important that this time is as short as possible. It is possible by set this using the potentiometer on the right to go to maximum anti-clockwise. This will set timing for 3 seconds. Now we can connect the motion sensor to our breadboard. Power goes directly to the battery, and the output signal, which is the middle pin, goes to wake up pin on the Cricket IoT board. So when we connect the motion sensor to the Cricket, we can do a quick test. We can simulate the movements, and we should see IoT module wakes up, and we should see the LED blinks. So let me explain how everything will works together. The Cricket board will be configured to send HTTP post requests to the webhooks, which is the part of IFTTT service. Webhooks will be configured to connect to the email service in IFTTT. An email service will be configured to send email to me with configured body and subject. So if we go to FTTT, we just need to create a new applet. We search for webhooks. We select the request. We can set the event name. Then we need to set an email, which is our destination. We can change the subject, we can change the body, create an action, and the whole service is completed. Now we have to configure the Cricket board. We can do everything in the cloud, in the Things on Edge service. The details how to configure that will be described in the blog, which will be linked in the description. Once we configure that, we need to connect the Cricket board to the local Wi-Fi. It's very easy process. Just press the configure button for more than 5 seconds till LED will stop flashing. Then we can connect using the phone, or we can use the laptop. We just connect to the network provided by the Cricket board. There will be a web service, which we need to put the Wi-Fi credentials and connect. The LED should start blinking. Once it stops, it indicates that Cricket is connected. So as I said at the beginning of the video, I would like this to be looks like a product, not the prototype. So I'm going to design the enclosure. To that, I'm going to slice it using the Cura app, and I'm going to use my 3D printer to print it. I will assemble everything together, and I will do the test. All the STL files will be attached to the video, so if you would like to build this yourself, you could just download. If you have a 3D printer, you can print it yourself, or you can use the online services to print the enclosure. So we see here if the movement is detected roughly about the 2, 3, sometimes 4 seconds, we receive an email with the topic we describe in IFTTT, and the body of the email also you can specify in IFTTT. It works great for me. I'm going to use it in my garage, and I will build another one and put in my shed. So if someone try to get into my garage or shed, I should have a notification. Thanks for watching. Please subscribe my channel. Thumbs up if you like it. Please put the comments if you have any problems. That should be straightforward. I really wish you will build this device like me. Thank you.